Before we start this video, large thank you to Flavio, Kale, and Bayo for their support on Patreon. I hope you guys enjoy the video. And an immense thank you to Halo Burner for their continued support of the channel this month on Patreon. It is greatly appreciated, my friend, and I hope you enjoy the video. Hey guys, real fast, so you can see here the camera is actually not going right in front of our player. If I click it here and zoom in, you can see it's to the right when we aim. That is not correct, that's my bad. So we're going to fix that right now. So go to where we handle our collisions on the camera, on the player camera, and right down here where we're setting the Z position of the camera, let's do a check for if we're aiming. And if we're aiming, we're going to make that Z position 0. Otherwise, we're going to set it as normal. So we're going to say if player.playerNetworkManager.isAiming.value, we're going to open up some brackets here and do return. Before we do that return, we're just going to set the Z position to 0. So what's happening here is basically when we're aiming, the actual position of the camera, the Z position of the camera object is changing, and it's going to change our alignment when we are actually zoomed in, which we don't want. So real fast, let's just copy this here now, and we're going to say camera position Z is equal to 0, and then save that. All right, cool. Now if I go back in the game here, you can see if I aim, boom, it is right in front of us and is facing the forward direction, which is the way it should be. So we're actually going to change a couple more things now too, because I was running some tests and I realized when I kind of ported this code over from my third person aiming, it doesn't translate exactly the same. So I'm going to make a couple more minor changes to make the arrow accuracy like literally directly on point. So go to the player camera, make a public vector3 aim direction variable, okay? So this is on your player camera, public vector3 aim direction. And now let's jump over to the player combat manager, and we're going to use that in just a moment. Oh, but before we do that, let's set that under handle aim rotations in the player camera. We're going to say aim direction is equal to camera object dot transform dot forward dot normalize. So basically, we're always going to make the aim direction when we're aiming the transformed forward direction of the camera. Make sure you say dot normalize as well. So let's save that, jump back to the player combat manager. Now under fire projectile, so this is again player combat manager, and then we're going to go down to the fire projectile function. First, let's make a header for the projectile itself, and we're going to locally make another direction variable here, private vector3 projectile aim direction. Now we're making another one here because we're going to adjust the one from the camera slightly and then send this one via server RPC. Don't worry about it for now. It's going to make sense in just a moment. So under where we have the is aiming to, where we're firing our projectile, we're going to make a local raycast variable called new ray. We're going to equate that to equal ray. Then we're going to say we're going to start at the lock-on transform because that's where our arrow instantiates. This is very important. You want to start that there. That's why I'm instantiating the arrow there to keep it all consistent. And then we're going to say the direction is going to be the player camera instance.aim direction. Now we want to get we're going to say new ray there. We want to get a point along this ray to fire the arrow at. And you can use a point that's very far away just so it's going to be basically always pointed in that direction. So I'm going to say projectile aim direction is equal to new ray get point, say 5,000. So this is never going to actually get the arrow to arrive there, but the direction is what matters. Then we're going to say projectile game object.transform.look at, and we're going to say projectile aim direction, like so. All right, and we can save that. Now, if we go into the game here now, we were to go over and aim and shoot, you can see it's going to mostly work, but you see how it's a bit lower there? And if I raise the aim, it's perfect. But then if I were to go really high, it will be off again. So this is happening because our camera is obviously at a different point than our instantiation point. So although they're looking in the same direction, check this out. I'll go to my camera here. You can see it looks down and it matches up when we're on the same level. But if I look way up, since the arrow is starting at a point that's kind of like above the camera, it doesn't match up. So if I take off the 3 here and zero out our aimed camera follow transform, it works a lot better, which is cool. You can see it's pretty much lined up most of the time now. And this is because now the camera sits at a point that's closer to the instantiation point, which is the lock-on transform, but it's not quite perfect. This will be fine, but instead of doing that, we're going to make it perfect. So we're going to go to the player. We're going to go to the prefab, delete this aim camera follow transform. Again, this is my bad because in third person, this actually works better for the accuracy and is what you needed to get it 1-to-1, but I'm transferring this from Nephilim, which uses third person. This is supposed to be first person like Elden Ring. So go to handle follow target now in your camera and delete the logic and just make it follow the player as normal. So now you can see we have a position on the camera where the camera pivot transform is 1.5 units higher. Basically just raises the camera so it's not looking at the ground. What we want to do is just basically make it so when we're aiming, we want to follow the player's lock-on transform position instead under handle follow target. And then let's go over to Player Network Manager now. And when we are not aiming, we're going to reset the player camera.instance camera pivot transform. So this thing here, because I just said, remember, it's got an offset, you can see here 1.5. That keeps it from looking at the ground. Let's store that as a local variable so we don't have to remember that number or use a magic number. We can say public float camera pivot y position offset. And I'm going to set it at 1.5 because that's working really great for us right now. We're not going to change that. So if we are not aiming, we're going to reset the camera pivot transform.local position. Local position is important by saying is equal to new vector 3 0 player camera instance y pivot position offset and then 0. So we're setting the y position to that 1.5 and we're zeroing out the rest as it normally is. And if you are aiming, set everything to 0. And now it will exactly place the camera on the lock-on position of our character. You can say vector 3.0 alternatively, by the way. And that will make it so we're actually looking exactly where the arrow instantiates. Now watch this. Now if I were to fire an arrow here, let's go down. You can see the lock-on target is in the exact same place as the main camera when I'm aiming. So when I go to load an arrow into this character now, let's do that. And I shoot, it's right on that dot. You can see as the arrow is traveling, it's right in the center point of that dot before it starts to drop. And that is perfect. You can see there, boom. So awesome. That is much more satisfying and feels much more correct. And the arrow is going to go where you expect it to go no matter where you're looking. So cool, that's done. Now we want to sync this as a server RPC so that if I fire an arrow in my game and I'm playing with you, you're going to see the arrow go in the same position as it does in my project, in your project. Meaning if I fire and hit a bullseye in my world, I want the bullseye to hit in the same position in your world, regardless if I'm locked on, if I'm free aiming, or if I'm just not aiming and not locked on and shooting. So go to the Player Network Manager. Let's make a server RPC. I'm going to use the tag here for server RPC. I'm going to make a comment here too, just so it's easier to see if I'm looking down in the future. So the green sticks out. Release projectile. So this one's going to be quite a bit easier than the code we wrote locally for our player because most of the work is actually already done. So notify server of release projectile server RPC. What are we going to require for that? Well, we need the client ID of the player who's actually firing the arrow, or you could also use the player object ID if you want to go about it that way. But since we're going to be the only ones here firing arrows for now, and when AI fires arrows, it will be a lot more simplistic. We're just going to reference the player's client ID. Next, we're going to need an integer for the projectile ID so we know which projectile to instantiate. And next, we need the X, Y, and Z position of the vector 3 direction of the arrow we need to be looking at. And then lastly, we need the Y character rotation. Why is this? Well, let's say I'm rotating my character as I fire the arrow. If the rotation doesn't update at the exact same time as I'm firing the arrow across the network, then the arrow will be a little bit off on my screen as compared to yours. So if I store the Y rotation as I fire the arrow and then send it, it's always exact. Just think about this. When you're rotating your characters, sometimes the rotation doesn't update at the exact same rate that you're shooting the arrow if you happen to be rotating while you shoot. It's a very niche edge case, but like it is an edge case nonetheless, so I like to include that. I've noticed it when playing Nephilim. So player client ID. Next, make a client RPC. And by the way, if any of this is unclear, please just shoot me a question in the comments and I can further explain. I know I'm moving quite fast, but I'm more than happy to explain each and every piece of this if something in this code is confusing to you at all, or you don't know why I'm doing what I'm doing. So client RPC, we're going to check to make sure we're not the character who sent the RPC. And if we're not, we're going to call upon a function that doesn't exist called perform release projectile from RPC. So basically, we don't want to run this on our end if we're the ones who requested the server RPC because we've already fired the arrow and performed that logic on our end locally. So there's no need to do that again for us. Of course, if you want to do that and set it up so logic is handled both on your end and on your end in another game here, you can do that. But I'm running it locally on the release projectile function of the player combat manager. And now I'm going to make the logic for my character in your game world here. So perform release projectile from RPC. Just copy all the variables again. You just need the ID for the projectile, the position, and the Y character rotation. Why is this? Oh, I accidentally copied the same variable here twice, projectile ID. So I'm just going to insert all these as well. The projectile ID, X position, Y position, Z position, and then the Y character rotation. All right, so what do we do here? Well, we can copy a lot of the logic that we already have in the player combat manager. So let's go ahead and yoink that. Now we're going to delete a lot of it, but let's just copy everything below the owner check for now. And then we can get rid of what we don't need, which is quite a bit of it. So right down here, copy all of this. Stop before you send the RPC. Obviously, you don't want to send the RPC again and cause an infinite loop. and then go back here and paste that. Okay, cool. So let's delete the checking for which projectile slot's being used, delete the ammo check. And now we need to make sure that this ammo is not null. So we have to check the world item database first as well, and then grab it from there. So we're going to say if the world item database.instance.get projectile by ID, and then we pass the projectile ID. If that does not equal null, then we want to basically just assign this projectile item variable as that. So we're checking the world item database first, or else you could get an error. It should never be null, obviously. If it's passing a check locally, this should always exist in the database on everybody's end. Everyone should have the same database, but just in case, we're going to do a check here as well. So range projectile item, I'll make the variable up here, projectile item, and then we can just say this is equal to the database getting the ID, and then we can progress and move on. So what else can we take out here that we don't need? Well, we don't need to, just at a quick glance here, whoops, I got to rename that variable the same thing. That should be projectile item. There we go. Just going to copy that here and paste that here. So we don't need the current ammo amount, and there's no reason to update a UI here. Oh, and I need to also initialize this at null, or else it's going to say that there's no variable to equate to. So get rid of this ammo count. We don't need to do that. And we don't need to do anything in isAiming. We're going to just do something different here. So if the player is aiming, we're going to say projectile game object.transform.lookAt, and we're going to pass the new vector 3. We're going to get a new vector 3 rather using our X, Y, and Z position. And that's it. It's just that simple, which is great. Now, if we are locked on, nothing changes. We're going to direct our arrow at the target that we're locked onto. That's perfect. At this point now, I'm going to go back to the player combat manager and pass all of our variables. So I'm going to say network manager.local client ID, or alternatively, you could also say player.owner client ID, and then pass the aimed direction. What did I call that? Projectile aim direction, I believe, and pass the projectile item ID. So projectile item ID, projectile aim direction X, Y, and Z, and I'm actually going to start spacing this out so you can see it. I'll make it drop down to the next couple of lines so it's not going way off the camera there. There we go. So yeah, we're passing the projectile ID and the direction that we're firing the arrow, and lastly, the Y rotation of our character. So this is going to be a local variable as well. Let's make that real fast. Right before you shoot your arrow here, what you want to do is make a float, and we can call this, you can call it Y character rotation, whatever you want. Whatever's clear. I'm also going to clean up these comments because they're a bit messy as we change the order of these things. There we go, that's better. So float Y character rotation when firing arrow. And again, this is very niche, but yeah, your rotation does update on the network as your character rotates. But when you fire the arrow, you want to make sure you're copying the rotation at the time that you fired the arrow, just in case the rotation update from the player network locomotion is a little bit later than when you shoot the arrow. So Y rotation during fire is equal to player.transform.local eulerangles.y. And we should be good now. Let's go in here and send that. Y rotation during fire. And then we're going to come over here, and this is temporary right now because, like I said, in the future we're going to adjust the arrow so we can aim up or down, because right now it's only going to go in the direction that the character is looking at. It won't take into account where the camera is looking up or down. So we are going to put in the Y rotation though. We can do that by saying player.transform.rotation is equal to player or quaternion Euler, and we pass the X and Z rotation that the player is already at, and we use the Y that was sent in the server RPC. So make sure you're doing this before you set the arrow rotation, because right after we're going to set the arrow rotation to the forward direction of the player, and this will change the forward direction of the player. All right, that's basically it. Let's save that. Now let's go to the damage collider, because right now we have no way to actually penetrate any objects in the game. So the arrows just kind of bounce off and look kind of silly and stick to the floor. It's not very nice looking. So let's create a private void for create penetration into object. So what do we need? We need a collision point, obviously. So let's pass a collision, call it hit. And then on collision enter, we're actually going to get rid of this has collided. Don't worry about that for now. Make a private bool called has penetrated surface and initialize that to false. And get rid of has collided. If we need to bring that back in the future, I will. Don't worry about it for now. It was going to be used for something that I found a better way to do. So we can just get rid of that altogether. Don't need to check for has collided right now. So under create penetration into object, let's say if has penetrated surface, or if has not penetrated surface, sorry, we're going to say has penetrated surface is equal to true. we don't want to on accident materialize more than one arrow that penetrates into the surface. We don't want to adjust anything more than once. So we're going to say create penetration into object and pass the collision. Now inside here, what are we going to do? Well, we need to do a few things. One is something that you might not think of unless you get to the point where it happens to yourself. Let's say GameObject.transform.position is equal to hit.getContact0. And then we're going to say .point. And next we're going to say variable empty object is equal to new game object. We're going to make a new game object at real time here. And then we're going to say empty game object.transform.parent is equal to, and then we're going to pass the hit.collider.transform. And then we're going to lastly say this game object.transform.setParent to the empty game object and then true. Why are we doing this? Well, if we don't do this and you actually penetrate the arrow into a surface that's scaled, meaning like a wall or a character you've made up or down, the arrow will scale with it and it looks really weird. So this stops the arrow from scaling up or down in size if it penetrates into an object that has been scaled up or down in size. So next we're going to say transform.position plus equals transform.forward times random.range. And then we're going to say 0.1 to 0.3 or something like that. This is how far the arrow will penetrate forward into the surface. So you can make a variable for this if you want for minimum and maximum penetration, or you can just give it a random set of numbers like this. If you're going to adjust this per arrow, definitely give it a variable. If it's going to be consistent for all of your arrows, you can keep it the same. I would always make it a local variable, though, honestly, if you think you're going to change it at all more than once. So next you want to disable the rigid body. And also let's go up top here, make a capsule collider variable, say capsule collider is equal to get component capsule collider, and then disable your capsule collider as well. So rigid body dot, sorry, we're not disabling rigid body, we're making it kinematic. Rigid body dot is kinematic is equal to true. Capsule collider dot enabled is equal to false. Then we're going to destroy the ranged projectile damage collider script that's on this game object. And then we're going to destroy this arrow after a set time. I'm going to say 20 seconds. Again, you can make this a variable if you want. Magic numbers are never good, but if you have a definite number that you're going to like, you're not going to change. If you've tested already, this isn't going to hurt, but I encourage you to definitely make it a local variable. So I'm going to add comments to all this now. This looks good. Whoops, this is supposed to be not vector3.forward. It's supposed to be transform.forward. So there we go. All right, let's save that. Now, if I go into the game here now in a moment, this should actually go into the surface and penetrate. You can adjust this number as you want. Let's go in here. I have a bullseye set up. You can see I've been shooting at it. I made this with just some regular geometry. You can see the arrow does indeed penetrate into the surface. Cool. So now let's go to our player network manager and actually call our client RPC. Didn't do that before. And let's test this out with a character and make sure it is exactly the same. Now, I am going to save you some time and just cut to these points in the video very quickly so you can see this is working. So I'm going to save this. Let's jump back into the game. I have two characters here. I'm going to shoot an arrow on my client. And you can see here it is in the host. You can see it here in this bottom left little area. Now, if I go over here to the client, you can see it is in the exact same area. And this works while aiming or free shooting. You can see, look at that, identically in the same place. Now, it also works for being locked on because the arrow is automatically tracking to the target you are locked on. Okay, now over here on Collision Editor, let's make a collider variable called contact collider. Next, we're going to say contact collider is equal to collision.getComponent.collider. Then we're going to say if the contact collider does not equal null, the contact point is going to be equal to contact collider. Then we're going to say dot contact, or closest point on bounds, sorry, then transform dot position of the arrow. So this will make it so our blood no longer instantiates in the middle of nowhere. It's going to be on the contact point. I go into the game here and boom, there you go. Back on the character it's striking. All right, let's stop destroying the game object now because we have arrow penetration logic. So delete that temporary code that was destroying the arrow after it hit a character. And then we're going to also check for a block, but we got to handle this a little bit differently. So let's override check for block, pass the potential target, not check for parry. Fun fact, you can parry arrows in Nephilim, although it's entirely pointless. It just stops them from hitting you. So we're going to override check for block. Now, what we need to do now is check the angle in respect to where the arrow is and not normally where you're being damaged from by the character that's hitting you. Because if the arrow hits you from side on, it doesn't matter where the guy who shot it from is standing to, it's going to hit you. So we do this by getting the angle of the arrow in comparison to the angle of the transform.forward of the blocking character. We can do that by saying angle is equal to vector3 angle, damage target, transform.forward, and we pass the transform.forward of this arrow. Obviously, we're going to say up top, if character's damage contains a damage target return, we don't want to check for block because they've already been damaged. Then we're going to say if damage target.character network manager is blocking and the angle is above 145, then we are going to say characters damage.add this character to the list, and then we're going to process blocking damage as we normally would. So we can instantiate a take block damage effect, call it block damage effect by instantiating it from the world character effects manager. And then we would just fill this out as you would normally with a regular block damage. So we can actually yoink all of that from any other damage clutter we've done this from, or we can type it in manually here. You can also say blocking damage effect dot character causing damage is equal to character shooting projectile. You might want to check to make sure that's not null though, because if you do something in the future, like, I don't know, put arrows on traps or make them fire up in the environment, then that's not going to be a thing that you're going to have. So we can say block damage effect dot physical damage is equal to physical damage, etc. And I am just going to yoink this at this point in time from the damage clutter. Go back to the damage clutter and take everything here like so, and then we're going to go back here and paste it. So this will change a little bit in the future when we add scaling to all of our items and effects and all that stuff. But right now we're going to keep it very simple. The logic is there, it works. We'll worry about calculating the numbers later, or you can do that on your own time because that's a very fun process. And everyone should do that their own way. So I'm going to add a to do here for make arrow bounce off shield or penetrate into the shield instead of the character if you are blocking. But we'll put that on a polish element or a future to do video because it isn't really all that important, unless you guys want to see it, in which case I can do it in the next one instead of moving on. Up to you. So if we go into the game here now, you can see if I actually run around, it looks normal. But then if I aim, I should be strafing, but watch. I kind of just do this walk in place thing. And also my movement direction is kind of messed up. My smoke detector is going off in the background, so apologies if you can hear that. So let's go down here now, and I'm going to remedy the strafing animations first. What we're going to do is go to the player input manager, and we're going to check to see if we are in fact locked on. And if we are, we're going to do the lock on stuff. And we're going to put the regular movement updates on the bottom here. So if we're not locked on, that stuff happens on the bottom. If we are locked on, we're going to check to see if we are locked on and we're not sprinting. We're going to send the horizontal input and vertical input, and then we're going to simply return. So just like this, return. And then we're going to do the same thing if we are aiming. We're going to say if we are aiming, we're going to pass the horizontal and vertical input, and then we're going to return. So basically, if we're not locked on and we're not aiming, we're going to eventually get to the bottom instead, where we will actually have the regular update animator movement parameters. Let's save that. All right, next go to the player locomotion manager, go to handle ground and movement, and we're going to make a check. If the player is aiming.value, do this, otherwise do the old movement. So if we are aiming, the movement direction, instead of being gathered from the camera, it will now be gathered from the player itself. So the transform.forward of the character and the transform.right of the character. And then we can save that. And now you can jump into the game here and you can see I'm able to strafe while aiming and my movement is normal, no longer inverted and weird if that was the case for you as well. So there you go, guys. We have a way to shoot projectiles on the server via aim, free, and lock on. We can move while we're aimed. We can aim down sight in first person, and the projectiles have penetration, which is pretty cool. So I can keep going with this. I can do some UI stuff if you guys want, and I can actually equip the arrows in the UI. I can add the bouncing off of shields, or we can circle back to that later and I can move on to something else. Let me know in the comments if you want to see something specifically. If not, I will move on with what I have planned. Thank you very much for joining me again this weekend. As always, guys, I hope you did enjoy the video, and I hope you all have a very lovely weekend. A special thank you to my patrons. It is because of each and every one of you get to keep doing this, and I really love doing this. So I will see you guys in the next one.